Hey, Alex.
Morning, David. Or afternoon, I guess.
Is Rachel going to lead, or is she available?
I am not sure.
Okay. Give it a few minutes and then you can kick it off and probably record it, whoever's the host.
Yeah, Shane's out. He gave me host, so I'll be recording it today.
Nice.
Looks like Rachel is also offline, so I'm not sure. Might just be us. Hey, Ed, do you know, is Rachel going to be on today? Ed might not hear us. No, okay. Give people another minute or so and we'll get started. All right. So we'll go ahead and get started. Give me 1 second to get my screen up. How's everyone doing today? I mean, obviously it's a live stream, so no worries. But we'll go ahead and get started now. I'm Alex Cain. There we go. Let me make sure I got the recording going here.
Recording in progress.
All right, good morning or afternoon for some people, including myself. I'm Alex Cain. I'm a senior solutions engineer with Cribl. And today I'm going to be kind of leading us through the Cribl Linux pack and kind of give you the highlights of it, kind of what it's geared towards and kind of where it's going, and demo it off to you. And then we'll open it up for kind of general office hour questions. So, all right. So we'll go ahead and just kind of dive right in. This is obviously the README for the Linux pack. I just wanted to hit a couple of things here. First of all, the Linux pack is geared towards two things currently. The Splunk TA for Nix. It's geared towards kind of ingesting the Splunk TA Nix data, specifically mostly around the Linux scripted events. It also does support repackaging the Linux scripted metrics inputs. There's not a whole lot done there, but there is some repackaging of the metric and kind of cleaning it up a little bit. And then thirdly, it also supports some Linux file system logs. The real gap there right now is just getting sample logs to work off of and clean that up. So hopefully as time progresses, we'll get a lot better at handling Linux file system logs. But as of right now, we handle a couple of logs specifically. So with that, I'll kind of dig in. There are a couple of suggested filter matching for how to route data into the pack. And I'll kind of show you how I've got things set up today in terms of how I route data into the pack. And we'll go from there. Okay. So let's go ahead and flip over to my actual routes. So I've got two routes that I route into my Cribl pack. First route is for anything that is not a Linux metric coming in from Splunk, that routes everything. This, in my case, I don't have anything other than Linux data coming in, so I can be a little bit more general, I'll say, in terms of how I bring data in. But the reason why I've split this into two packs is, or two routes. One is for routing into one Splunk dev environment, and one is routing to a different Splunk environment. That being said, you can kind of manage things differently in terms of how you want to match out sending data into the pack. So if we go and look at the pack, this is how the pack is set up internally. We've got Linux file system logs as our first kind of pull out. Anything that ends in a .log is what runs through this. Hopefully, again, like I said, this will grow out more. Next is the Linux events. So I'll kind of look at the filter here briefly. There is a lot in here, but really the way we handle things is we look at the source type and then match to make sure that it does not contain metric. We do pretty much something similar, so long as it contains _ metric and has one of the predefined Splunk inputs for that. We will get into kind of the nuts and bolts of the Splunk TA if people have questions for it, but we can go into the scripted event input right now. Let's go ahead and start with this. So in the TA, or in the pack, there are sample events for pretty much every single input. There's still a few that are missing, and I hopefully will have more over time. I've also included the bots trimmed sample pack, but I might kill that just depending on the size of the pack. So let's go ahead and start with kind of the most egregious one. For some of you that are familiar with the Linux data, you get some crazy events. In this case, the PS event log, a single event comes in like this. Now, when Splunk indexes it, they have some props and transforms that breaks this out into single line events. There's a couple of ways to approach this. And I'll kind of show you two different ways and how you can change that in the pipeline to match kind of how you want to handle this data coming in. But first and foremost, most of the data coming in from the Linux TA has this kind of header, and then it's almost like a CSV format where you've got this header and then rows are log lines. Well, we had to build this processing group to be able to actually extract out, based off of the different event types, how to remove the header, match that against the log lines, and fix everything. So what we get with PS is a nice, clean, multi-line event with each line being retagged as a JSON. So we can kind of step this back a little bit and we'll kind of see how that looks over time. So if we remove kind of some of the post-processing, and let's go ahead and open up our PS section here. We'll remove the aggregation. So when we just go through, break the data, like the event into sub-events and kind of clean it up, here's what we get. Unfortunately, because that one event has now turned into a massive multiple entities, right? We've turned 5 events into 980, which, you know, sometimes that's needed. Sometimes you really don't want to do that. This won't save you size unless you start trimming things down and cleaning up. But if we look at kind of some of the things that we've done, right? We've gone through, we've extracted the actual event out of that huge thing, and we get, you know, the actual values We've reserialized it back into raw. The only thing that we could do here that would make a big difference in terms of just repackaging would be dropping all of the unnecessary fields, the ones that we've extracted here in the green. The aggregation, this is really where we repackage everything back into that kind of structured event. This will definitely help in your size. There's some questions in terms of, what is it that you really need from these logs? You can definitely save more if you want to actually go through and drop events based off of what's actually being commented out, right? Another option here, and maybe this is something that we can incorporate once we get some community feedback, is dropping events that are unnecessary or off of specific users or by different commands. I think that's something that is really going to be more up to the community to determine. But hopefully this is at least a good starting point for a lot of you to be able to start working on what's that next step past this. So PS is kind of a difficult one. It's a bit nasty in terms of looking at it, right? Let's look at a couple other events and kind of see how that comes out. I know for a lot of people, we'll do Unix service events. So Unix service events can be kind of gross as well. You get a lot of white space built in. And there's it's kind of like this mixed case, right? Where you get the timestamp and then you get key values. Some of them are comma separated, some of them aren't. Let's go ahead and look at what we do here. So what we're able to do with Unix service events is actually clean this up a good bit. And we get, in general, a 33% drop and a full event drop of 46%. Again, key values are turned into JavaScript or a JSON format. This is something, I don't know, again, if the community prefers a different format, we can definitely add that in as an option. But at least for now, it's a lot easier to incorporate and get the auto extraction once it's into Splunk. Go ahead and flip over to time events. So this one I want to call out. So time, I'm not sure how many of you are familiar with time events. Time events in Linux come in as this kind of interesting table format. What it's about, or what the reason of the time event is, to be able to tell whether the server's time, system time, is off from the local network time. So it reports back from a selection of local time servers and tells you the time skew with the margin of error. And so what we've done in the time, I think, is actually quite interesting, where we go through and here, let me actually turn off a couple of these functions so it's cleaner. So when we go through, we evaluate each of the rows because of the information coming in. So this first line in the event actually tells us whether or not the information coming from that server is trustworthy or not. So the first thing that we do is we actually drop anything that is untrustworthy. So we kind of break apart understanding what the different symbols mean and get rid of anything that is either questionable or downright known to be wrong. So what we get is just the simple field with the knowledge of, okay, what's the actual skew, what's the unit in, and kind of work from there. Unfortunately, and this is kind of the frustrating part, is that it reports error margin and skews in whatever unit is reported to it. So sometimes they're in milliseconds, sometimes they're in nanoseconds or microseconds or seconds. So what we end up having to do is actually convert skews all to seconds and then evaluate the skew against the margin of error. And then the final thing that we do is we do a drop on the margin of error against the skew. And what we're looking for is if the skew that is reported from that server plus the margin of error is greater than 0, and the skew minus the margin of error is less than 0. So what that would tell us then is that the margin of error is greater than the actual skew from the server. So when we do that, we drop the events, and we actually end up, in this case, with no events left. In the case that we would actually have events left, there's an extra added aggregation to just kind of tell you what's the min, max, and average skew and the number of hops between that server and the local server, and just report that out as an aggregate. That's an option to do if you want to report on that. Otherwise, with the drop command, you end up cleaning up a lot of these logs anyways. All right, so flip over to a couple of other events. Do something similar with Unix update. So I was able to actually kind of get most of the Unix and Linux log types to be worked with a pretty simple set of kind of functions. But what we end up with is kind of cleaning up the repeated logs and kind of the more already pre-aggregated logs and just write out, in this case, this is telling you, okay, hey, there's this package that's ready to be updated, or hey, there's this other package that needs to be updated. So what we end up doing is just kind of rewriting that out, cleaned up, without really doing a whole lot. We do reduce the actual event size about 45%, and overall event size almost 60%, and cut down the number of events by a good margin as well. Actually, that's even without the aggregation or the cleaning up on. So with the post-processing group, converting it back to JSON, we actually get almost 65% reduction just on this one event type. CPU events. So this one's kind of interesting. I'm kind of just hopping around to some of the more interesting ones. Coming in, CPU events just tell you what the kind of average load is and individual load is across your CPUs. Again, it's hard to know kind of what exactly is useful and what's not. I've kind of taken my best stab at it. One thing I will call out, I've tried to write out in each of the subsections here what the actual fields are, and trying to share as much information as possible in here so that if you want to make changes or kind of edit something, you got as much information as possible at your fingertips. One other thing I will call out is each of these does have a comment just kind of telling you how much you can expect to see as a decrease over the specific event. In the case of the CPU events, just restructuring it as a single report out for all. So I think, yeah, I dropped individuals and just left the all. We're able to see, an 82% reduction in raw length. So, it's something that is, again, hopefully the community will kind of give some guidance, and we'll see this pack just get better and better over time. Top is essentially the same as the PS. I won't kind of go into that one. We will take a look at LSOF. Let me pull up that one. So LSOF is a bit interesting. Coming in, this is what LSOF looks like. And there's a lot of information in here. And the hard part is kind of, again, figuring out what's useful in here and what's not. One other thing I will call out, and it's something that hopefully will get we'll be able to work around. But the TA actually formats this incorrectly. So after you're scrolling through this for a while, there is a point where everything skews. I will show you here in 1 second. And unfortunately, there's just no way to get that data back. It cuts off data and it just drops it. And there's no way to correct it. Let's see if I can find where it goes. The problem is specifically on the way Splunk handles sub-processes, or specifically the TA handles the sub-processes of a system. So if I just keep scrolling down, I can find it. Oh yeah, actually I'd already done that. So as you can see here, you've got this number, and you get Splunk D, Splunk, right? But that's actually where it's already skewed. So where is it? As you can see, there's a lot of them that's skewed. Right here. So what it's supposed to be is process, PID, user, and then kind of all the information past that. When it spawns a sub-process, the TA script doesn't know how to handle a sub-process. And so it creates it as if the sub-process PID is now the user, and then it skews everything off. So unfortunately, from this point on in each of these logs, the data just kind of gets skewed, and it's really hard to know what happens. So coming out of that, what we end up doing is actually just building an aggregation of this, because the data itself coming in from LSOF is pretty irregular, to say that at best. So we actually go through and count processes by command, and user and PID. So long as it's command user PID, we count the number of processes, we'll sum the size. So all of these aggregates then run off of the command user and PID. This is really about the best way I could figure to come up with cleaning up the LS log. It's since it's broken, the actual data coming into it, and I checked with the TA as well, when it writes into Splunk, the events that are skewed off like that are also improperly skewed inside of the individual events in Splunk. So the best way I could figure was to kind of come in and rebuild this as an aggregate and just kind of tell, okay, what's actually happening here. And maybe it's worth doing a duplicate aggregate, just relisting each of the events. We'd be interested to hear what the community's thoughts are over time, just kind of how to best handle that log. But unfortunately, it is broken just from the log coming in. Did as best as we could to kind of fix the structure, and I at least rematched the broken lines against the user. So it is fixed as much as possible, but for those lines, it did lose the last two values of that event. So just be aware. If we turn this off, we can actually see what that looks like. LSOF, because of the size of the log, it does take longer to run. Just be aware as well. So as you can see, we do pull it out and restructure it as if it's a single line event. Again, that's a huge percentage up. So as best as possible to kind of either restructure that as a single event or as an aggregate is really your best option in handling this. So that's kind of it for the events. I mean, there's other pieces here that are interesting to see, but I'll let you guys explore that on your own. I'll flip over to the file system logs now. So currently, file system logs support DNF, KDump, and tuned. And I'll kind of show you a couple of those here real quick. So we'll kind of go through these one at a time. Anyways, let's just go ahead and flip to the out. So this is part of KDump, and we have restructured the KDump log, and if we flip back over, so this is what's coming in. Some of it is key value. This is obviously command line, run image, and then kind of the values in that string. So if we look in the out, we get the init D, right? The command line, and then command line boot image, and all of this. There's definitely more massaging that can be done on these events. This is kind of the first pass on some of the logs, and hopefully, again, this will get better. If we flipped over to, let's pull up a tuned log. Here's a tuned log. So tuned logs, there's not a whole lot of information coming in from tuned. It is pretty just, stopped tuning, tuned daemon, right? Terminated. So we kind of just pulled out what log level to expect if something is coming in that's not info. Here we get a warning. So we are extracting the log level. There's a couple of debug level. So there is post-processing that could be done in terms of, do you want to keep your debug logs? Do you want to keep info logs? Do you want to wrap them somewhere specific? That's definitely something you can do, and it's built into the tuned logs. So now I'll flip over to the metrics, since there's not a whole lot to show. Thanks, metrics. So start with the interfaces metric. So coming in and coming out, we get a bit of a cleanup here. There's not much in the raw length cleanup, but in the full event, we do about a 20% cleanup. Should hopefully see a bit of a performance improvement. But again, that's something we'll see over time. If we look at, for example, VM stat. VM stat's not much, actually. Okay. So again, all of these are, that's why I'm pulling in the events. Anyways, all of these, let's actually get the metric correctly. DF metrics. All of these are in here as either metrics or events. Just make sure you're clicking on the right one. There's about a 13% reduction just on the DF metrics. It's hard to get a whole lot of reduction from the metrics events, but would be happy to hear kind of people's take on it, or if an aggregation is something that would be useful for some of these. One thing I will call out is on the TA. So if we go into the TA here, it depends a lot on the intervals that you're looking to ingest things on. Obviously, there's not a whole lot of scripted metric inputs, but on the event inputs, the timings kind of vary wildly, and it really just depends on what you're looking for from your logs. If you're pulling in certain logs a lot more often, you'll see a difference in terms of your actual performance or reduction of data coming in. But at the very least, if we take a look at LSOF, every 5 minutes, writing that giant thing, or every 10 minutes. With CPU, you're writing it every 30 seconds. And this is default, right? This is the default config from the TA. If you're writing more or less, that's going to just make that even more or less kind of important. If we go back at the VM stat metric, okay, so here's the actual VM stat metric log. Coming that in, that one actually we see a bit better improvement. So it's a 33% reduction on the full event length. Yeah. So that being said, I will kind of leave this here. I will flip back to the information page. I'm hoping to get this up online onto our repository today or tomorrow. And would love to start getting feedback. Otherwise, it actually will be posted into the Slack channel in the PAX channel later today. And feel free to ping me on the community Slack for any questions, or if you have any information that you want to get on this. Also, my inside of here, my contact is in here, so feel free to shoot me an email. My one outstanding ask for anyone who does want to start working on this or using it would be, I need some more Linux file system logs to start working on it, and I need input. So I've got a couple of people providing some information, but anything that you can kind of throw my way would be a huge help in terms of just making this pack all that better. I will go ahead and stop sharing. If anyone has any questions, this will be available later today. So. Is there any questions on the Linux pack I can kind of go over? Otherwise, we can also open up to just general questions. Yeah, you're welcome, Jeremiah. I know that was a pretty, a lot of just information thrown at you. So hopefully you'll all be able to download it, play with it, and kind of get some thoughts on it. There should be enough sample data in there to kind of test each and every single one of the sections in the pack and pipelines. That's good to hear, Pete. So Pete says that they've got a lot of OS logs. Again, there's not a whole lot there from just the system logs. I just got, I downloaded the bots log pack, but unfortunately there's not a whole lot of usable data there. So if you can send over some sample logs, I'd be more than willing to help improve the file system log kind of pack area. Yeah, that's definitely one of the weaker sides right now is the file system logs, but hopefully over time we can get that a lot more cleaned up. I would be actually really interested to hear from people, if anyone wants to share in chat, what format they would love to see in terms of like output from file system logs or like the Linux scripted events. If there's no real preference, I'll probably just stick with JSON since it's.
So this is Pete.
Yeah, hey Pete.
So for all the performance stuff that we have, we don't have a huge volume of that, but the stuff we do have is kind of messy, and we only use small portions of it. So I think just a lot of cleanup that you're showing there and dropping of what we don't need could still help out a lot.
Yeah.
When I look at our Linux OS logs, we have. I just had it up, but I think it's something well over like 100 gigs a day of that in our Splunk environment. And when I look at them, they look pretty messy to me. I've never been a Linux admin, but I feel like there's a lot of room for improvement there. So I don't know if they have any access to ex-Linux admins that might be able to help out with that stuff.
I hope so. So actually, I wanted to show this really quick. This is distributed from Splunk. This is the bots TA or the bots app to practice for the boss of the sock thing. But
Yeah.
I just want to point this out. This is from the who source type, and this is true for almost every single one of the source types in the TA. There's
This
your
is from
header.
the performance.
It's
TA,
the header.
right?
Yeah, this is the performance from, you'll get this on the DF, you'll get this on every single one of those logs. They pull in the header as an event.
Yeah, we saw that. We only turned on, I think, maybe 6 or 7 of those scripts in the performance TA, and that's the kind of stuff we were seeing. You know, I think it was the CPU one, or maybe it was PS. That's like, I mean, it's like 50 lines long of different performance metrics that we only use. For example, the CPUs, it has metrics for each CPU, and then there's an all, right?
Mhm.
That's the only one we use is the all. Obviously, that's an easy one to clean up, I think.
Yeah, like this, the top event is just as bad.
Yeah,
It's just a straight up,
exactly.
it's the output of the top command written to a log.
Right.
And it's, how useful is that? Yeah.
Oh, wow.
So this at least cleans all of that up. You're right.
Yeah, so it's nice to get that cleaned up. So I think I'll take a look at this. I'll probably throw it. You said it'll be available later today.
I'll be posting it into the PAX channel on the Cribl community, and then once we get the dispensary repo stood up and posted, then I'll get that posted on the PAX channel as well.
Okay, very cool. I'll look out for it.
I would love, yeah, actually, that's a good question. So David just asked if there's any comments in terms of performance benchmark from the time to take to process some of these. So let me turn on my internal fields and I'll actually show you what the processing time is for some of these. So I'll just share my screen one more time. So on all of these pipes, if you want to see the actual time to process these, just turn on your internal fields and you see __A, and this will post the start time, the end time, and the actual duration. So not too long, 101 milliseconds. I think it's in milliseconds. It's just timestamp. So yeah, milliseconds. Okay, so other events, we can pull up a couple here. If we look at time events, time events are not good because they kill it. Let's look at bandwidth events. So bandwidth takes 12 milliseconds. You're gonna make me do PS, are you? Oh, sorry, no can do. I repackage it so the ag function kills it. How about LSOF, since you're so curious, David? Again, this is impractical because this is 5 LSO events in one go. You know what? I repackage LSOF as an ag. So anything that's have as an aggregate loses the duration field. So just an FYI. If I turn off the aggregation, this one will be interesting. It's going to be long. Yeah, it broke. Okay. So be wary of turning off aggregation for LSOF unless you really, really, really want to. Just one thing I will share, how we got the PS events restacked as that one event that houses everything. Sure, I'm doing this right. This is, yeah, there we go. So how we got this to run as one event with everything in. We did an aggregate that's just a list of source, list raw. So what we did was just basically create an event listing all of the raw items. I would be careful just to call out that we are grouping this by host, source, and index. So if you don't group by host, you could blow up this event quite quickly. So be very careful on that. I will call it that we are also just doing a 15-second time window for this raw kind of collapse. That's mostly just because when the TA is writing this out, or the PS events are writing every 30 seconds by default. So if you want it to be multiple PS events and you like, I just really care about like a 5-minute window, that you can span out, but be careful because it's going to really blow up that event size. It's better to kind of repackage it just as one and kind of see where that takes you and play with it from there. So just a pre-warning on collapsing PS events is that it could be a lot larger than what you're expecting. Just not from a writing out perspective or index size, because you're still getting a reduction in the size, but larger from how is the pipeline actually processing events, and you might run out of memory for your pipeline. So just be aware of that. Okay. All right, any other questions? Otherwise, yeah, I think we can call it. We'll give people a few minutes back. All right, well, happy Wednesday, everyone. Hope you have a great rest of the week. And I will, again, post this to the PAC channel in the Cribl community here in just a little bit. Thanks again.
Thank you.
Recording stopped.
you.